Okay, so my project is on periodic trends and electrons and energy and electron configuration and ionization energy. Okay, so my project the first topic I want to cover is the periodic table. So the periodic table is divided up into rows and groups or families. The rows give reference to the energy level, and the groups slash families or columns are a group of numbers that will give you the number of valence electrons. The periodic table is also divided into metals and nonmetals. Properties of metals are they are lustrous, ductile, malleable, good conductors. Because of their low ionization energies, they are often oxidized in reactions, and they increase as we go down and to the left of the periodic table. Some properties of nonmetals. They're on the right side of the table. They form anions. They're good insulators. Gases are brittle solids. And it's a good idea to memorize the Brinkelhoff twins. Other things we can tell from the periodic table are atomic radius, ionization energy, electron affinity, and electron negativity. The first topic The second topic I want to cover is electrons and energy. So the first thing is Coulomb's law, which is going to relate the distance between molecules and the strength of their forces. Then we can look at Bohr's model, which is going to show when heated elements release light. The release of light is due to electrons absorbing specific amounts of energy and then releasing that energy as light. We then can look at wavelength, which is the difference between two repeating points on the wave. It's often measured in nanometers or meters. Frequency, or V, is the number of waves that pass in a second. It's measured in hertz or seconds. Waves, frequency, and energy. Frequency is going to be and wavelength are inversely related. So C equals wavelength times frequency. Energy, frequency, and energy. Energy and frequency are directly related. E equals HV, E being energy, H being Planck's constant, and V being frequency, again measured in hertz. The The third topic I want to cover is electron configuration. This is going to be based on energy levels and sublevels. So the electrons on the energy level are located on certain energy levels. There's a maximum number of electrons that can be placed on each. 2n squared is the number of electrons that can be placed on the energy level. So energy level 1 is going to have 1 electron, energy level 2 is going to have 2 electrons, energy level 3 will have 3 electrons. Sublevels. On the energy levels, we have sublevels of where the electrons can be. So S, P, D, and F. S is circular. P has a dumbbell shape, which has 3 axes, X, Y, and Z. The fourth topic that I want to talk about is ionization energy. So as you go across the periodic table, ionization energy increases, and as you go down the periodic table, ionization energy decreases. So ionization energy is a quantity of energy that is isolated. Gaseous atom in the ground electron state must absorb to discharge an electron, resulting in a cation. So for example, hydrogen in its gas form is the same as hydrogen plus 1 electron. This energy is usually expressed in kilojoules per mole, or the amount of energy it takes for all the atoms in a mole to lose 1 electron each. The final topic I want to talk about are PES diagrams. PES stands for photoelectron spectroscopy. High energy UV or X-ray protons are aimed at a substance. If electrons absorb enough energy, then they can overcome their force of electron. That's called the photoelectric effect. The detector will then determine what energy level and how many electrons were ejected at that point. So for example, on the diagram on the right, the smaller peaks represent 2 electrons, while the higher peaks represent 6 electrons. So this could be 1s2, 2s2, 2p6, 3s2, and then 3p1.